Okay, good morning. In the previous class, we discussed about the definition of Z transform, region of convergence, and properties of ROC. That is region of convergence we discussed, and also we have taken a few examples for finite sequences. We have solved three numericals on finite sequences for right-sided, left-sided sequence and double-sided sequence. Today we'll be discussing how to find the Z transform for infinite sequence for both right-sided, left-sided and double-sided sequence. Okay. Okay. So this problem I have already discussed. So let us revise. Given x of n is a to the power n u of n, it's a decaying exponential. Since a of n is multiplied with u of n, we know u of n is 1 for n greater than or equal to 0. So in that case, x of n exists only for right-sided. That is only for positive values of time n. So in that case, the infinite summation x of z equal to summation minus infinity to plus infinity, it will be changed to 0 to infinity, a to the power n, z power minus n, because u of n is 1. So n equal to 0 to infinity, a power z minus 1 all to the power n. In this, I am taking n common. So by using geometrical infinite summation series, so we can simplify this as x of z is 1 by 1 minus a z to the power minus 1. Okay, so if you simplify 1 by 1 minus a by z, you will get z by z minus a. So x of z exists only for the values of z for which it is absolutely summable. That means always x of z should be less than infinity. Suppose if you observe this, x of z is z by z minus a. This is the expression for z transform. I need to find out for what values of z, x of z is a finite value. Suppose if you consider this denominator, suppose if this denominator becomes 0, then z by 0, x of z will become infinity. That means for a given signal, x of z doesn't exist for when z is equal to a. So that means except a. So if you simplify any values of z, then x of z, it should be a finite value. So that means this z minus a, it should be what? It should be greater than 0. Okay. So this you can say, or I can take this term also, 1 minus a z power minus 1. It should be greater than 0. Then only x of z, we will get some finite value. So when we simplify, you will get mod z greater than mod a. That means the value of z for which x of z is a finite value is for the values that is which is greater than a. So now coming back to this expression, x of z is z by z minus a. In this case, if you can see, the numerator will give you the number of zeros and denominator will give you the poles at a poles on a plane. Okay, so now if you observe, so we have 1 0 and 1 pole, 0 at z equal to 0 and 1 pole is at z equal to a. So if you go back and see, study the properties of ROC, ROC will always make a circle of radius which is equal to the pole. So in this case, the pole magnitude is A. So 0 is at 0 and pole is at A. So which makes a circle of radius A. Okay. So now ROC, I need to represent it on a Z plane. Z plane is what? It's a complex plane with x-axis being a real part of Z and y-axis being a imaginary part of Z. So A is a pole which makes a circle of radius A, and we found out that ROC is mod Z greater than A. That means region of convergence for which x of z becomes a finite value, it should be greater than a. That means the values which are greater than a, in this case, it is the values which lie outside the circle or exterior to the circle. The shaded region represents the ROC for a given positive time exponential sequence, that is a to the power n u of n. So always remember, for a right-sided sequence, it may be a in this case it's an infinite sequence, always ROC is exterior to the highest magnitude of the pole. So in this example we have only one pole, that is z is equal to a. Suppose in some cases we may get z by z minus a, z minus 2, and z by z minus 3, something like that. So in that case I need to consider the highest magnitude. Suppose we have in the denominator z minus 2 into z minus 3. So in that case we'll be having two circles. One is at the magnitude 2 with a radius 2, and the other circle will be of radius 3. So, and where will be the ROC? ROC will be exterior to the highest magnitude of the pole. That is, it is outside the magnitude of the pole, which is equal to 3. So always for positive sided, ROC is exterior to the highest magnitude of the pole. For this problem, ROC is mod z greater than a. Now, coming to the next problem. So it's a negative time exponential sequence. So when you plot this, so when you plot this sequence, okay, so it will be from minus b to the power n, u of minus n minus 1. So that means u of minus n minus 1, it will be from n is equal to minus 1 to minus infinity. So you will get the graph like this. This is 0. This is at point minus 1. So minus 1 to minus 1, it is minus 1 to minus infinity. It's a exponential. So now we'll try to find the Z transform of this. So we know u of minus n minus 1, it is 1 for n less than or equal to minus 1. So it is from minus 1 to minus infinity, and 0 for n greater than minus 1. Okay, now let us use the Z transform expression. X of z is x of n z power minus n, and simplify x of n with this expression. Okay, and by applying this, so we will get x of z is, I am taking minus outside, n equal to minus infinity to minus 1. This u of minus n minus 1 is 1. So we will be left with b to the power n z power minus 1. So now let us take n common. So we will get b by z to the power n, and this is minus 1 summation n equal to minus infinity to minus 1. So now we need to make this term to plus 1 to infinity. Okay, since we don't have a geometrical series to simplify this, so we need to make this as negative range as positive term. So what we will do is just we will simplify n is equal to minus m. So in that case, we will get m is equal to 1 to infinity, and this n will become minus m. So it will become b to the power minus m and z to the power 1 by z to the power minus m. So by modifying this, I can make z by b whole to the power m. Okay. Now we have the summation 1 to infinity. I need to make this summation to 0 to infinity. We know that for 0, what will be the term z by b whole to the power of 0 will become what? 1. So that means to convert this infinite summation to 1 to infinity to 0 to infinity, what I'll do is I'll just add and subtract 1, plus 1 and minus 1. Okay, and you can see here this is minus 1. So minus 1, suppose we have z by b whole to the power of 0, that term is also minus 1. So now if you combine these two terms, okay, minus m is equal to 1 to infinity z by b to the power m, minus 1. Minus 1 is nothing but what? Z by b whole to the power of 0. So by combining these two, I can write, okay, so I can write m is equal to 0 to infinity z by b all to the power m, and this term, this plus 1 term will be as it is. So now for this, we know what is the expression. 0 to infinity, it is 1 by 1 minus a. Okay, so in this case, a is what? Z by b. So simplifying, I'll get x of z is equal to x of z is equal to this 1 minus this term, 1 by 1 minus z by b. Okay, and when you simplify by taking the LCM, you will get x of z is equal to z by z minus b. Now, this is the z transform. How do we find ROC? This z minus b, it should be what? It should not be equal to 0. When this term is equal to 0, x of z will be z by 0, which becomes an infinite. In that case, x of z does not exist for a given sequence. So that means we need to select the z value such that it should be except z equal to b. Or what we can do is, just you take the denominator 1 minus z by b. This should be what? It should be greater than 0. Or you can, if you want, you can consider this also. Z minus b should be what? Greater than 0. Or z should be what? You will get, it should be z minus b greater than 0. Or z should be what? Here, z 1 minus z by b, it should be greater than 0. Or 1, it should be greater than z by b, or b is greater than z, or z should be less than b. So we will get the ROC mod z, it should be less than b. So you can see both positive and negative exponential sequence. In place of b here, if I put a, you should have got a z by z minus a. See here, if you see, what is the z transform of this? Z by z minus a for x of n, a power n, u of n. So if you see this example, in place of b, if I put a, then also I'll get z by z minus a. Expressions z transform for both positive as well as negative sequences are same, but the difference is ROC. For positive exponential sequence, ROC is mod z greater than a, whereas for negative time exponential, it is mod z less than b. If I take b as a, you will get mod z less than a. So z transform for both positive as well as negative exponential sequence, it is same. But for positive exponential sequence, ROC is exterior to the circle of radius, which is equal to the pole, whereas for negative exponential sequence, ROC is interior. It should be less than b. Means it should be interior to the circle of radius, which is equal to the magnitude of the pole. So let us see this, how we will plot. So if you see the Z transform expression, we have one 0 and one pole at equal to b. So 0 at 0 and pole at b. And what is the ROC we got? Mod z less than b. So this pole always make an circle of radius which is equal to b. Okay. So in that case, and ROC we found out that it should be less than b. Less than b means it should be inside the circle of radius b. So what we can conclude that, so for both exponential sequence, whether it is positive or negative, we will get the same Z transform. Expression will be same. But ROC is exterior for positive going exponential and interior for negative going exponential. Okay. So now let us take the next example, double-sided sequence. What I'm doing here is, I've taken positive sequence, a to the power n u of n. Okay, so that is same as the previous problem which we solved, and the second sequence is minus b to the power n u of minus n minus 1, that we have uh, previously discussed problem. Okay, so we know that what is the Z transform of this? Z by Z minus A. And what is the Z transform for this? Z by Z minus B. So we have just solved that. Just a second. We have just solved these two problems. The same way, in this case, X of n is just the addition of these two. And the taking the Z transform, we got Z by Z minus A, and here Z by Z minus B. It is the combination of the last two problems, positive going exponential and negative going exponential, and we found out Z by Z minus A and Z by Z minus B as Z transform of these two sequences. And since it is a positive going exponential, we found out ROC was mod Z greater than A. And here this is a negative going exponential. So the ROC is mod Z less than B. So now when we combine these two signals, always, or any two signals, then ROC is always the intersection of these two. Okay. So now let us take, so ROC is mod Z greater than A for the first signal, and it is mod Z less than B for the second signal. It is the intersection. It should be greater than A, but it should be less than B. So when we intersect, we will get ROC mod Z. It should be greater than A, but it should be less than B. That means it should be the intersection between these two ROCs. So we will get the ROC as mod A, which is less than Z, less than B. So now, how do we plot in a ROC? How do we represent ROC on a Z plane? So now, as I told, always the pole will make a circle of radius of magnitude of that pole. In this case, A is one pole and B is another pole. If you see here, A is one pole and B is another pole, and we have two zeros here. Okay, so now A, and this is one this is one circle with the radius B. Now, where is the ROC? ROC lies between A and B. A and B means this is the shaded region. So this is the ROC for the combination of positive as well as negative sided sequence. So for between A and B, whatever the value you take, so that will be that is the range for which X of Z is a finite value. So if you see here, if you take this example only, if I make Z by, if this term will become 0 when Z equal to A, that means infinity I'll get. So similar way, if I substitute here Z equal to B, B minus B, then also it will become 0. So Z by 0 becomes infinity. So we want X of Z should be less than infinity. So in that case, I should omit the value which Z which is equal to A, and I should not consider the value of Z which is not equal to B. So that means I need to accept the value of A and accept the value of B. I can consider any other values. So in that case, I can get only the finite value of Z between the range A and B. So this shaded region gives the ROC for this double-sided exponential sequence. So these are all basic problems on Z transform. So next we'll discuss properties of Z transform. Okay, so till now we have discussed the numerical problems by using the Z transform expression. Okay, so now we will study few important properties of Z transform. Then we'll be solving the numericals by applying those properties onto the signal. Okay, so we have very important properties. I think around 7 to 8 properties are there. The first property is linearity. So we know linearity is nothing but the superposition. That means if we combine the sum of the weighted two signals, whether it may be a Z transform or it may be a Fourier transform or Fourier series, we will get the Z transform of the superposition of those two signals. Okay, so let us discuss this. Suppose Z transform of x1 of n is given as x1 of z with ROC Rx. So in this case, we don't know what is x1 of n. Suppose if I consider x of 1 as a to the power of n u of n, whose ROC may be mod z greater than a. Okay. So x2 of n, if I consider it as minus b to the power n u of minus n minus 1, in that case, ROC may be mod z less than b. So generally, we'll represent it as Rx and Ry. Those are the ROCs for the given Z transform x1 of z and x2 of z. So suppose if I take some of the weighted discrete time signals, if I apply the Z transform on some of the weighted two discrete time signals, that means if I take Z transform of A1 x1 of n plus A2 x2 of n, then Z transform will be represented by A1 x1 of z plus A2 into x2 of z, whose ROC is nothing but intersection between these two signals, Rx and these two ROCs of x1 of n and x2 of n. Okay, now we'll prove this. So Z transform of A1 x1 of n plus A2 x2 of n is given by summation n is equal to minus infinity to plus infinity. We know the expression, right? So x of z is equal to summation x of n z power minus n. So in this case, x of in place of x of n, we have what? A1 x1 of n plus A2 x2 of n into z power minus n. So now we'll simplify this summation. Sum n equal to minus infinity to plus infinity A1 x1 of n and z power minus n plus A2 x2 of n z power minus n. Now we'll take A1 and A2 outside the summations. N is equal to minus infinity x1 of n z power minus n plus A2 into summation n is equal to minus infinity to plus infinity x2 of n z power minus n. So now if you observe this expression, so this is same as x of z expression, only the difference is in place of x1 of n, we have x of n, we have x1 of n. So I can write this as x1 of z plus A2 into this term as x2 of z. So if we apply the Z transform on some of the weighted two discrete time signals, then Z transform is whose Z transform is given by sum of the weighted individual Z transforms x1 of z and x2 of z, and whose ROC is represented by intersection between the ROCs of the individual signals. So in this case, ROC is Rx intersection Ry. So next important property is time shift of translation property. Suppose I have a signal x of n, discrete time signal, okay, whose Z transform is represented with x of z and ROC is Rx. Suppose if I shift x of n by n naught units, n naught can be positive or negative, in that case, the Z transform is given by x of z, okay, x of z multiply by what? Z power minus n naught. Okay, so all these properties again we will be discussing with some examples. Suppose let us assume I have 1, 2, 3 and 4. X of n is this. Suppose I shift this signals towards left by or right by 2 units. Okay, so if I shift this signal towards right by 2 units, then so in place n naught, if I write 2, okay, so this will be what? Z power minus n naught. That means Z power minus n naught value is 2. Z power minus 2 into x of z. So you just find the Z transform of 1, 2, 3, 4. That is your x of n. Okay, suppose if I ask you to find out the same signal, but that signal is shifted towards right by 2 units, then whose Z transform is given by x of z is what? Z transform of x of n. You just multiply the x of z, that is the Z transform of x of n, with the factor z power minus n naught. What is minus n naught? N naught is what? Number of times you have shifted. So in this case it is 2. So it is z power minus 2 into x of z. You have found out x of z for this. Just multiply with z power minus 2 with the z transform of this. You will get the z transform of this signal x of n minus 2. Okay, so but ROC will remain the same because I am not changing the characteristics of a signal. Signal will remain the same, only it is shifting towards right or left. So ROC for a given signal will remain the same. Okay, now we'll prove this property. Z transform of x of n minus z power x of n minus okay, just a second. N minus n naught. N is equal to minus infinity plus infinity x of n minus n naught into z power minus n. So let us take this n minus n naught as m. So what is n? N is equal to m plus n naught. When n tends to minus infinity, m also tends to minus infinity. When n tends to plus infinity, m also tends to plus infinity. So now we will simplify. Replaced with what? M plus n naught. So now we will simplify this exponential, that is z power minus m and z power minus n naught. Now I'll be taking this z power minus n naught outside the summation, and if you see this, this is m is equal to minus infinity to plus infinity x of m z power minus m. Equation looks same as Z transform. In place of m we have what? N. Sorry, in place of n we have m variable. So this is nothing but your Z transform. So I can write Z power minus n naught into x of z. So Z transform of any time shifted signal is given as x, the Z transform of the original signal multiplied by Z power minus n naught, where n naught is what? It's a shifting factor. How many units you have shifted the signal. In this case, ROC will remain the same. Now, coming to the third property, multiplication by an exponential. So, suppose I have a signal x of n, whose Z transform is given by x of z with ROC Rx. Okay, so if this x of n signal, if I am multiplying with a to the power n, then whose Z transform is given as x of z only, where z has to be replaced with z by a, whatever the value here a, okay, that has to be replaced. Z has to be replaced with z by a. Suppose we have x of n with x of z. I ask you to find out the Z transform of 2 to the power of n x of n. Then it is same x of z. Wherever z is there, you have to replace it with what? Z by 2. Okay. So in this case, if for x of n, ROC is Rx, then in that case, if you are multiplying x of n with a to the power of n, then ROC is also multiplied with what? The factor a. A is an exponential factor. So if it is 2, a is 2, it will be 2 into Rx. Okay. Now we will prove this property. So Z transform of a to the power of n x of n is written as n equal to minus infinity plus infinity a to the power of n x of n z power minus n. Now x of n, I am taking n outside, n common in these two terms, a and z. So I'll get a into z power minus 1 whole to the power n. So now we know what is the z transform. X of z is equal to n is equal to minus infinity x of n into z power minus n. So in this case, in place of z, what I'm having? A into z power minus 1. So this is nothing but x of, if I give you to find the z transform of x of n, it is x of z. But in this case, in place of z, what I am having? A into z power minus 1. So z has to be replaced with what? A into z power minus 1, or I can write it as z by a. So ROC, in this case, it is multiplied by a factor, that is a. Okay. So the next important property is multiplication by a ramp. So in case of discrete time signal, we will represent multiplication by a ramp by a factor n. Suppose if x of z is the z transform of x of n with ROC Rx, then if I multiply the given signal x of n with a ramp, then its z transform is given by minus z dx of z by dz. And in this case, the ROC will remain the same. Okay. Now, we'll prove this property. We know z transform of x of n is given by x of z summation n equal to minus infinity to plus infinity x of n into z power minus n. Okay. So, differentiating this equation with respect to z on both the sides, I'll get dx of z by dz equal to the summation x of n, and I'm differentiating this. So I'll get minus n z power minus n minus 1. So dx of z by dz. So I am taking z power minus 1 outside the summation, that is minus z power minus 1 I am taking outside the summation. N is equal to minus infinity plus infinity. What is left? N into x of n into z power minus n. So now, and I am just modifying here. I am taking this minus z power z inverse to the left hand side. So I'll get minus z dx of z by dz equal to n equal to minus infinity to plus infinity n x of n z power minus n. Now you just compare equation 1 and 2. This n is equal to minus infinity to plus infinity x of n z power minus n. This is the z transform of x of n. Now, in place of x of n, what I am having here? N x of n. That means z transform of n x of n is given as what? Minus z dx of z by dz. So, in this case, ROC will remain the same. Okay. Next important property is convolution in time domain. Suppose I have two signals x of n and y of n. We know suppose to represent the output of any LTI system, we use convolution sum. Suppose I have two signals x of n and y of n. The response we can compute using the convolution sum. That is x of n convolute with y of n. So in place of impulse response, we have taken it as y of n. So which is equal to summation k is equal to minus infinity plus infinity x of k into y of n minus k. H of n minus k is replaced with y of n minus k. Okay. In this case, suppose if z transform of the first signal x of n is x of z with ROC Rx, and z transform of y of n is y of z with ROC Ry, then if you want to compute the z transform of its convolution, which is nothing but the multiplication of the z transform of those two signals. Okay, so convolution in time domain is nothing but multiplication of multiplication of z transform of those two signals in z domain. So in this case, the ROCs are different for these two sequences. So if you convolute, the ROC will be the intersection between Rx and Ry. So now we will prove this property. So Z transform of X of n and X of n convolute with Y of n is given as n is equal to minus infinity plus infinity. In place of X of n, I need to represent this. X of n convolute with Y of n Z power minus n. Okay, now summation n is equal to minus infinity plus infinity. Let us simplify this expression. X of n convolute with Y of n, that is represented by the convolution sum x of k into y of n minus k. So this this is nothing but your convolution sum expression. So now in this, let us simplify n minus k with m. Then n will become what? K plus m. So by modifying, when n tends to infinity, m also tends to infinity. When n tends to minus infinity, m also tends to minus infinity. So this n summation is replaced with m, and this will we will keep it as it is, k equal to minus infinity plus infinity. Now x of k will also be remain as it is. Now n minus k is replaced with what? M, y of m it will become, and z power minus n is replaced with what? K plus m. So now what we will do is k is equal to minus infinity plus infinity, x of k I am taking, and here z power minus k I'll be taking. This I'll consider it as one term. The second term is m is equal to minus infinity to plus infinity, y of m and z power minus m. So if you observe this, okay, in place of n I have k. So that means this expression can be written as what? Z transform of x of k, that is x of z. Similarly, in place of n I am having m. So I can write this is a Z transform of the signal y of m. So what we can conclude is convolution in time domain is nothing but multiplication of the Z transform in Z domain, and the ROC is the intersection between Rx and R5. Okay, next we'll move on to one more important property, that is time reversal. Suppose I have a signal x of n whose Z transform is x of z with the ROC Rx. If I fold that signal, what is it? Z transform. If I suppose I have u of n, okay, so u of n, you will find out what is a Z transform. Suppose if I ask you to find out Z transform of u of minus n, so in that case, the Z transform will be x of 1 by z, or I can say x of z inverse. And ROC also it will be changed to what? 1 by Rx. So it will become inverse because z is becoming 1 by z. Similar way, Rx also becomes 1 by Rx. Okay. So whenever you are doing problems on properties, if you just calculate the Z transform of this, okay, for this example only. So for u of n, you calculate what is x of z. For u of minus n, what you need to do? In the same expression, you just have to replace z by 1 by z. That's it. Okay, so you don't have to calculate from the derivation. By applying the properties, you can easily solve the problems. Okay, appropriately. So in this case, ROC is Rx. So if you fold the signal, then the ROC also it will become the inverse, that is 1 by Rx. So now we'll prove this. Z transform of x of minus n is nothing but n equal to minus infinity plus infinity x of minus n into z power minus m. So now let us replace minus L with L. So what we will get? X of L into z power L. So x of L, z power L, I'll write it as z inverse all to the power minus L. If you see this expression, this is same as Z transform expression. X of Z is x of n into z power minus n. So in place of Z, we have Z inverse. In place of L, in place of n, I am having L. So I can write this as x of Z inverse, because in place of Z I am having Z inverse. So which can be written as what? X of 1 by Z. So in this case, ROC also, it will be the inverse, that is 1 by Rx. So this completes the properties of Z transform. We studied 6 properties. Linearity. So linearity, you can observe here, linearity, we are taking 2 different signals. So that's why the ROC is intersection between those 2 ROCs. So in time shift, only we are taking Rx. So ROC will be retained it as Rx only. Multiplication by an exponential. So in that case, ROC is multiplied with the exponential factor, that is A. Rx, ARX. Multiplication by a ramp. Here also we are having only one signal. So ROC will remain the same. Okay. Now, when it comes to convolution, we are dealing with 2 different signals with 2 different ROCs. So ROC is intersection between 2 ROCs, that is Rx and Ry. So when it comes to time reversal, we are dealing with only one ROC Rx, but in this case we are folding the signal. So ROC will become inverse, that is 1 by Rx. So this is all about properties of Z transform. In the exam, they may ask any 2 properties. Two important properties. This property, multiplication by ramp, we also called as differentiation property of Z transform. Okay, please make a note. Multiplication by a ramp, we also called as differentiation by a ramp. This is very, very important, one of the important property, and the other one, time shifting property and convolution also. So they may ask you for stating the property and prove those properties. So out of 6, any of the 2 to 3 properties they will ask in the examination. Okay, so I think for today I'll wind up the session. So tomorrow we'll be discussing some numericals of standard signals like delta n. What is the Z transform of delta n? What is the Z transform of U of n? Okay, so some standard signals Z transform will discuss with their ROCs. Then we'll solve some numericals by applying the properties of Z transform. So if you have any queries, please let me know. I'll discuss now. Understood the properties? Students?
Yes, ma'am.
Understood the properties? Yes? Okay, please try to practice all these properties. Okay, I think you have studied this in your maths also? All these properties? Yes? At least linearity and time shifting, those properties you have studied?
Yes, ma'am.
Okay, then it will be easy for you to understand. Only difficulty is with ROC, because that concept you have not studied in maths. Okay, maybe that is the difficult thing for you. Okay, so when we solve the problems, that concept also it will be clear to you, ROC concept also. So tomorrow try to practice all the properties which I have discussed today, and also the problems. So tomorrow we'll take up some more numericals. Okay. Okay. Thank you.